everyone, and welcome to the one and only video for today. We'll be going over something called compound inequalities. But before that, let's take a look at what inequalities are one more time. On page 73, remember there's this nice little chart right here that reminds us, based on effectively where the alligator symbol is going to face, is going to determine what is bigger and what is smaller. Remember, it likes to eat the bigger one. Now, an example of this, right, is this right here. Take a moment. What does this mean? If you said x is less than 3, you are correct because the alligator is eating the 3. So 3 is going to be bigger than x. We didn't talk about this yet, but I do want to talk about this real quickly because we're going to be doing this today. But if I wanted to graph this, the way we would do this is we would take a look at x being less than 3, and we remind ourselves that if it has a line underneath it, if I was going to graph it, it would have a closed circle at 3. But if it doesn't have a line underneath it, like right here, it'd have an open circle. See, these two examples don't have any lines underneath the alligators. So I put an open circle at 3 because it does not include 3. It's everything less than 3. So what are some numbers less than 3? Isn't that like 2, 1, 0, -1, -2? So what I'm going to do is I'm going to draw a line right here, and this represents everything here being less than 3. And this represents your x right here because it doesn't include 3, open circle, but everything below it does have a line with an arrow continuing onwards. And that's how you graph this, and I think hopefully this should be review for everyone. And if it's not, then, well, use this as a reference, okay? Now, let's talk about what the actual topic is today. What if we had an inequality, 2x plus 3 is less than 9, but what if we wanted to take this one step further? What if we added another inequality and we made it compound? Notice this has two inequalities now, and our x is directly in the middle. It's not as crazy as it seems, but this is called a compound inequality, where instead of having one restriction, it has two. So let me show you how you would solve this and graph this. The way this is going to work pretty much is that whatever you do to the middle to get rid of this 3 and this 2, you must do to both sides of the inequalities. So in this case, the first thing I should do is give this plus 3. So I'm going to subtract 3 here because that'll cancel out right there. But not only am I going to subtract 3 there, I'm going to subtract 3 on the left side and the right side. See that? Now I'm going to simplify it so that we have 2x, and then -5 minus 3 is -8, and then 9 minus 3 is 6. Notice nothing happens to inequalities, they just drop down because we didn't divide or multiply by a negative number. Now I still haven't solved for x yet because I see a 2 right there. 2 times x. The opposite of multiplying by 2 is to divide by 2. So I divide that by 2 because it's going to cancel out. But just to keep that balance, right, I'm going to divide by 2 on everything also, on the left side and the right side. So in the middle, we know it's going to be an x, right? So let's do the left side now. -8 divided by 2 is -4. And then 6 divided by 2 is 3. Now we have this nice simplified inequality. And I see x is going to be between the numbers -4 and 3. So if I was going to graph this, I would have, well, if it's greater than or equal to -4, I put a nice big dot on -4. And because it's less than 3, I'm going to put a nice open circle on 3. And because x is in between them, I'll draw a line right there. And that's one example of a compound inequality. But there's another way we can handle this, guys, so I'm going to show you the other example now. And the other example is, what do we do if it's an OR situation? What does this OR mean? Well, I feel like you're not really understanding what OR means until we see the graph. So let's just try to simplify this. If you're ever given this, where you're given two inequalities and it's OR, what you have to do is solve them separately. So on the left side, I have 2x is less than or equal to 6. I should just divide by 2 because that's going to cancel out right there, right? And then 6 divided by 2 is 3. So I have x is less than or equal to 3. So that's good so far. Now, we have the other side of the OR, which is 3x is greater than 12. So I am going to, instead of divided by 2, like I did on the left side, because it's a separate inequality, I need to get rid of this 3, I could just divide by 3, right? Because that'll cancel it out right there. And that gives us x is greater than, well, 12 divided by 3 is 4. Now, we still have this OR right here. So you're probably wondering, what does that mean? What does that OR mean? I'm going to show you right now. Let's graph the left side. This says x is less than or equal to 3. So I'm going to put a closed circle, a filled in circle, because it has the line underneath it. And then remember, what is less than 3? Isn't that 2, 1, 0, negative 1? So I'm going to draw my line right here. Now, I'm going to do x is greater than 4. Now, I don't have a line underneath that alligator, so I'm going to put a open circle. And then it's supposed to be numbers that are greater than 4. So wouldn't that be 5, 6, 7, 8? So it looks like this. So this is what we mean by or, guys. Notice how, unlike the previous one, where it was just one line between two dots, it's the opposite, where it's two dots and lines that go in opposite directions. So this is why it's an or, because either it's going to be on the left side or it could be on the right side. Either one would work for this situation. So these are compound inequalities, guys. It just means more than one inequality or more than one restriction. I'm going to give you a few practice problems, and then we're going to work on this a little bit more on our really quick day of Tuesday. Get that work done, guys, and I'll see you then. Have a good day. Bye.